G'day viewers. In this segment I'll talk about HTTP caching and web proxies. So we've talked about the performance of HTTP just for requests and responses, fetching content. HTTP caching is an important technique which can be used to improve performance by enabling the local reuse of content. And in this segment I'm going to tell you how it works. So the motivation for web caching is that users often revisit the same page. They're looking at the same content. When this is the case, there's a big win that's waiting to be had by simply reusing the local copy. That is, if you remember what the page looked like the last time you visited it yesterday and it hasn't changed today, or most of it is the same, such as many of the images, because the site looks the same, then we can reuse all of that and avoid transferring that content over the network. This is called caching. And so you can see in the picture here, I have the client over on the left in this case, the server on the right, and what's new here is this big cache. We're going to try and draw web resources from this cache rather than from the server across the network. Now the key question when you have a URL that the browser's been instructed to fetch by the user, the key question that we need to consider with caching is, when is it okay to reuse a local copy that you happen to have in the cache? If you have an entry for the URL that you're trying to fetch, great, everything sounds good, but you've still got to know when you can actually make use of that copy. That copy might have changed on the server, in which case you don't want to present the old information. But it might also be the same as what's on the server, in which case you would like to use it so that you don't transfer it across the network anymore. So, how are we going to do it? Well, there are a couple of different options. Let's see them. The first option that you can use is to try and locally determine whether the content copy that you have in your cache is still valid. Valid means that it has the same contents as would be returned to you by the server if you were to request it again. How are we going to do that though? This is sort of getting a little circular. To do that, we would really like to use meta information which came from the server when we retrieved it last time. For instance, if the server includes an expires header which gives a timestamp and says this copy of the content is valid until this date, well then our test to determine whether the local copy is valid is simply checking the time and seeing if the document has already expired, and if it hasn't expired, it's good. This would be wonderful if there was always an expired header. There isn't. Sometimes browsers will fall back on heuristics. This is not ideal in that these heuristics could get it wrong, but usually it's helpful in terms of performance. So a heuristic is just a rule that provides a guess. So if you were the browser and trying to guess whether content was a copy of content which is in the cache was still valid or not, you might look at several factors. One rule that's used is if the content is of the kind that looks like it's cacheable, meaning it doesn't have any headers, any meta information that says it's not cacheable because it was produced dynamically, for instance. So if it's cacheable, and if it's freshly valid, you got or validated a copy of this with the server recently, like maybe a few minutes ago, and it hasn't been modified recently. The copy you got, it might have a header information to say when this content last changed. Say it changed a year ago. Well, if it hasn't changed for a year and you just got a copy a few minutes ago, chances are it's going to be okay and it won't have changed. So this is a heuristic that browsers might use. They can be wrong. In that case, the page you're looking at can be different than the page which is on the server, and there's a small amount of inconsistency. Mostly they'll be right. When you use these local determinations and you end up with a copy that's still valid, the advantage is that you get the content right away. So you get it with near zero latency and with zero network cost. So this is definitely a win where you can do it. In fact, it's a huge win. And you can see that I've just drawn the box around everything local. The cache and the client are all local behavior, so the network's not even involved here. It's in terms of cutting down on network usage, it's the best we can do. But even when we can't locally revalidate the copy because we don't have an expires header and we're unwilling to guess, there's also there's a second strategy we can use, which can greatly help by reducing the amount of information we send over the network. And that is to revalidate the copy with the remote server. Revalidating the copy involves talking to the remote server and asking them if the copy you have is still valid. If it is, then you've won even though you contacted the remote server, because you don't have to transfer the information across the network again. Well, how are you going to ask the remote server if your copy is still valid? One way you can do it is based on a timestamp. When you downloaded the contents, it probably had a timestamp saying when it was last modified. You can ask the server if this URL has changed since this last modified timestamp. If it has, you'll have to get a new copy. If it hasn't, well, the copy you have is still valid. Alternatively, instead of timestamps, sometimes headers are used which are based on the contents of the resource itself. This can be done with an e-tag header. It stands for entity tag. It might be a hash or other indication of the contents of the file. And this is information that, again, you could send to the server and say, well, I have this copy. Is there anything more recent than this copy? Assuming that you can contact the server and validate the local copy you have, then the advantage is that you get content after about one round trip time. It will be at least a round trip time to send a message to the server and to hear back, yes, you can use it. But in this case, even though we've waited a little longer than with the local case, we've transferred essentially no information, very little information across the network. We haven't had to do the large transfer of 0.5 megabyte of information to move the resource again. So these are both big wins. Now, I've talked about two different methods, but actually these methods are used together. So here's what it looks like when you put these different pieces together. Here's the sequence for a user trying to browse a URL, and if possible, we'd like to use cached copies. So first of all, we get the request when they type something into their browser. What you can do first is perform a local check on your cache. This is checking the expiry. Do we have a valid local copy? Suppose that it can't be determined that you do. If you do, you're done. But if it can't be determined that you do, then we're going to revalidate our copy with the server. The way you revalidate the copy with the server is to do what's called a conditional get. It's a get because we'd like to get the resource, but it's conditional because we only want to get it if our copy is not valid. So we would send header information such as describing the copy we have, when it was last modified, or what its contents was. If in fact our copy is still valid, the server will respond with a not modified code to tell us that the copy we have is still valid. And in that way, we can simply get the copy out of the cache here and display it. On the other hand, if the page has changed, then the server in this lower path would respond by sending a full large response. So I'll write large, and this is small in terms of content, so we'll win. Either way, we get it from the cache or it gets sent, and then we display it. So that's how web caching works. As well as web caching, so far I've really talked about caching inside the browser. I'd like to talk about another web entity which can be used for caching and for other purposes, and that's something called a web proxy. So a web proxy is an intermediary that you would place near a pool of clients, and it would act on behalf of those clients, providing web transfers for those clients when they're interacting with remote servers. So what will happen here is that all of the clients will send their requests through the web proxy. The proxy is then in a position to act as a big cache. So the benefits that it will provide for the clients are that it can run a bigger cache, and it can also provide a little bit of sharing across users. We'll get to that too. As well as security checking. Actually, a big reason for proxy caches is really the security checking and organizational access policies rather than plain caching. These access policies, this security checking might involve things like scanning the contents that are sent back to make sure that it's not full of viruses or other nasty things you can pick up just by surfing sites on the web. So a proxy is something that might be run by your local IT organization in your enterprise. They've set it up and they'll manage it to provide a better service, a more secure web service or more secure web experience than you and I and everyone having to maintain their own computer and inserting all of these different security checks. Now, the organization also benefits in that it can provide, or enforce rather, organizational access policies. Your organization might have policies about what kind of sites you can surf through the corporate firewall, and if you try and surf other things, then those connections just won't go through. Your organization might even have policies about what information you can send outside of the company, just to try and prevent confidential information from leaking. So proxies perform all of these different services, and this is why they're sort of useful from an IT perspective. The reason we're mentioning them now is because of this caching role. A proxy provides a local point at which caching can be provided for a pool of clients. This provides a few benefits for the clients. So first of all, the size of a cache at a proxy can typically be larger than at individual clients because it's probably a more powerful machine that's been set up and is managed by your IT organization. More than that, there is a shared cache, shared across users, I mean. So if you and I work at the same organization and you've recently been surfing some sites and I browse them later, I can benefit from your surfing because I might get a copy from the cache that you pulled in the first time you visited the site and it had to be fetched. I can then get the copy from the proxy rather than having to go to the remote server. However, caching in a proxy, as with caching in your browser, is limited in some ways. Caching is generally not effective for secure content. If you've retrieved something with secure protocols like your online bank interface, we usually don't share or cache and share that information across users. That would create more security problems. Caching is also limited by dynamic content. Many pages, if they're produced dynamically, they will depend on all of the program inputs instead of the database. So they're often not cacheable. If you want to look at them again, you have to recreate them. And caching is also limited by what we call the long tail, in that while there's some popular content that can be cached well, there's a very large number of unpopular pages. And these comprise a significant fraction of usage that caches can't do much about. So let's see how web proxies really work just with this picture. So you can see here, I have the pool of clients here. Here are all the clients here. And they might also have all of their browser caches already. They could get a hit on that and that would short circuit things. But if they're trying to request things that they can't satisfy from their browser cache, what they will do is they will send all of their requests to the proxy. So the client needs to be configured not to talk to remote servers directly, but to send all of its requests to the proxy. All of your web browsers have built-in functionality for doing this. The proxy will then be able to consult its cache in much the same way as you would check a browser cache, and it will be able to share the contents of this cache across users when there are no security issues. And if you miss in the proxy cache, then you'll have to go all of the way to a remote server and back. Now, since the proxy is close to you, it's really within your organization, you would expect to get a much faster hit if you simply request content from that proxy and it's able to supply it locally than going out to the internet. So that's a proxy, a web proxy, and it's providing another level of caching as well as all of these other kinds of filtering to provide a better web experience.